The next part for 5.2 is factoring perfect squares. So perfect square trinomials are when we are going to be able to factor it into the form a plus b in parentheses squared or a minus b in parentheses squared. When we factor these, it is going to be a trinomial, so you will have 3 terms that you are starting with. So when we were doing difference of squares, we had 2 terms that were perfect squares. Now we're going to have 3 terms. The first term and the last term, when we're factoring these, we are checking, are they perfect squares? And then the middle term, so this is true if we're adding or subtracting, the middle term we are checking, is it equal to 2 times our a value times our b value? And we're not really paying attention to the sign for that. The sign is going to come in when we decide, are we adding or subtracting in our factored answer. But for these, we just need to figure out, is 2 times a times b the same absolute value of that middle term? So let's look at 2a. The first thing, like always, you want to check for your GCF. That will affect if you have a perfect square at the beginning and the end. So make sure you are checking for that. At the beginning, we have a coefficient of 9. So that would be a 1, 3, or a 9. We can factor a 3 out of 12, but we can't factor a 3 out of 4. So we do not have a GCF other than 1 here. So we're not going to change anything. Next, because we have 3 terms, we want to double check. Do we have a perfect square for our first term? So 9x squared. That is a perfect square. We would get a 3x. And then do we have a perfect square at the end? So square root of 4. That is a square because it equals 2. These are going to be our a and then our b values. So to factor it, having a perfect square trinomial, we need to double check that if we take 2 times our a times our b value, does it equal 12x? So if we look, our a was, so we'll do 2 times our a of 3x times our b of 2. And when we multiply these, 2 times 3 is 6, times 2 is 12, and we still have that x. So because it works, and we have 2 perfect squares at the beginning and the end, we are able to factor it. So in our parentheses, we would start with our a value, 3x, and then our b value is 2. The way you can tell if it's positive or negative is based on that sign in front of our 2 times a times b term, so our second term. Because this is positive, we need a positive in the parentheses. And one thing that is super important that you want to make sure you do not forget, 3x plus 2 is not equal to 9x squared plus 12x plus 4, unless you put a squared out here. So if you forget that squared, your answer is wrong. You need to make sure you put that squared on your parentheses, and it should be on the outside. Once you have that, that is your final answer. So looking at example 2b, let's do another example together. So you're going to look for your GCF. It's always our first step. This one, our first coefficient is a 2, and all of these are even. So that means we can factor out a 2 there. So looking at this, we would have 2 on the outside. That would leave us with x squared minus 8x plus 16. Now, it's really important when you factor out that GCF, you are remembering to factor it out from all of your terms. That is a common mistake that we forget to do when we are factoring it out. So make sure you are checking for that. Now, inside the parentheses, we have our 3 terms. So we're going to check, can we factor using our perfect square trinomials? So we're going to check, is our first term a perfect square, square root of x squared equals x, and then is our last term a perfect square as well. In this case, they are. So x is going to be our a value, and 4 is going to be our b value. So we need to check that 2ab is equal to 8. That's what we're looking for. So if we take 2 times x times 4, that does in fact equal 8x. So we are able to factor using our perfect square trinomials. And if you forget this, you can still use AC split to factor them. So that is still an option. So if you forget the perfect square trinomials, you can default back to that from last unit. All right, so the GCF2 has to stay in the front. That is part of our answer. And then the inside the parentheses, x squared minus 8x plus 16, we're going to factor that into our a value, x, and then our 4 in parentheses squared. And remember, the second term up here shows us if it's a positive or negative. So because it's a negative second term, we're going to subtract. And again, don't forget your squared, otherwise your answer is completely wrong. All right, so those were 2 examples that we walked through together. You can pause and try the last one on your own, or you can continue to watch through till the end. So first thing we're going to check for is our GCF. In this one, we can divide all of these by 3. When we factor that out, again, you're going to factor it from every single term, so we'll be left with an x squared plus 8x plus 16. Now we have 3 terms inside of the parentheses, so we're going to double check. Do we have perfect squares for our first and our last term? In this case, we do. We get an x and a 4 when we take the square root of those. And then we're just going to double check that 2 times a times b equals that 8. So if we take 2 times x times 4, that does in fact equal 8x. So we are able to factor using our perfect square trinomial. Don't forget, again, the 3 in the front, that has to stay there. So we would have an x and a 4 in the parentheses, and because this 8x was positive, we are going to have a plus in between them in our answer. Once you have that, that is your final factored answer. That's how you're going to factor a perfect square trinomial. The next one is going to be talking about difference and sum of cubes.